briefly afterwards. But we'll start with our talk today, which is a very, very special talk on the Edison Street tubes in William Street, the world's first commercial underground electricity mains. New York and London are the only other people who used it at the same time. So we have our research engineers. I think they've got it briefly up on the screen there. From Brian Becconsall and Stuart Wallace from the Engineering Heritage Queensland. They're giving us this wonderful talk about the tubes being invented by Thomas Edison in 1891 and used Brisbane to connect the Queensland Government Printery power station to new electric incandescent lighting in Parliament House in 1896. Parliamentarians, of course, were sweating under hundreds of gas lights at the time. As soon as these blokes across the road got electricity, they put their hand up, please, we want our building lit by electricity, and that was what happened. So Thomas Edison came just at the right time. So I'll briefly introduce, I think, is Brian going first or Stuart? Brian, okay. Brian Becconsall, retired electrical engineer, a fellow of the Engineers Australia, a long-time member of Engineering Heritage Queensland. Spent 48 years in the Queensland electricity industry, starting as a cadet with SEAQ in '56. Graduating from UQ in 1961, worked overseas in Canada and USA for 2 years, Queensland with QEGB, QEC and Powerlink Queensland in high voltage transmission, before he retired in 2004. Brian was involved in the first 1992 dig for these tubes, where they found enough to show that they were definitely there, and they cut them up into little pieces, unfortunately. And they found them in William Street by Energex in the Queensland Museum of Researchers John Mackenzie and Emeritus Professor Sid Prentice. And then finally he was involved in the recent recovery of them earlier this year. Stuart Wallace is a retired electrical engineer, a fellow of Engineers Australia and an active member of Engineering Heritage Australia in Queensland. A graduate of both QUT, which was then QIT, and UQ, his career over 40 years was mostly spent consulting in the fields of power generation, transportation across the globe. His keen interest in electrical engineering history is both professional and personal, and he is the 4th generation engineer and 3rd generation electrical engineer. So I'd like you to welcome our speakers, and Brian to the floor, please. Thank you.
Thanks very much, Dean. With that introduction, I almost feel a bit of heritage myself. You pickle me and bottle me soon. Well, we're coming of electric light to Brisbane. You know, the researchers in the United States and England, Europe, you know, were playing around with a lot of electricity in the early 1800s. And they never quite got to commercial type use of electricity until the end of the 1800s. So the 1800s was a great period of industrial and scientific exploration. But it took somebody to persevere, try this, try that, until they finally came up with an electric light bulb that was going to be commercially available. And that really sparked the whole of the electricity industry going in Australia, worldwide. And we weren't that far after the overseas people in the United States and England. So, bottom one. Right. Thrown me a bit because it got out of sequence. The electric light demonstrations in Brisbane. The first electric light demonstration was in 1882 with arc lighting. Now, arc lighting had been around for a while in England. It had been developed for lighthouses, but you've seen, you know, what arc lights are like. They're terribly intense. They're no good for indoor purposes, but they're great for outdoors, for lighthouses. So that sort of didn't take on. The council wouldn't come to put it, wouldn't agree to put it in the streets at that stage. They were dominated by the gas interests. But some private industry were experimenting with lighting. So Sutton's foundry, he put lighting in. He put both arc lighting and incandescent lighting. And this was just after Edison developed the incandescent light in 1879. So there was a trial in the printery. The printery people needed light to work at night. They were under gas lighting, so they cottoned onto this trial of electric lighting. Parliamentarians thought that's a great idea. We'll do the same thing, and so they put in an order at that same time for Parliament House. But before Parliament House was hooked up, the Queensland Railways had electric light, had arc lighting at their Rama Street yards. Brisbane Newspaper Company, they installed indoor lighting. So let's come to the Edison street tubes. How did they come about? So the colonial government, and after that trial, decided that this was a pretty good deal. We'd love lighting instead of this hot gas lighting. So they, for that quote from the Edison Company, the Edison Company worked through Alfred Shaw and Co here. They put in an order for permanent incandescent lighting of both the Printery and Parliament House. It would involve 2 Edison dynamos, 30 kilowatts, and 500 lamps for both places. Now, it's all very well to have, at that stage of the development of electricity industry, nobody ran electricity very far from the generator. The generators are operating at DC, not AC that we have today. So DC had its limitations on how far you could supply. So Edison had to come up with some street tubes. As well, the government hadn't thought about a power station building for the bigger power station, so they let contract for the power station building, Andrew Petrie to build that. The steam engines from Smelly and Co. These names will all ring a bell to you. And Alfred Shaw to extend more lights to the council chamber. And they finally thought, how are we going to get the power down to Parliament House from the Printery? Because that was the suitable place for the power stations. We need 1,500 feet of underground mains to get the power down there. They could have gone overhead, which would have been cheaper. But the councils at the time were fairly restrictive on what could be put overhead. Edison had developed the underground concept of underground mains and connection boxes. And so they were available, and so they went in. These are the power plants. That's Sutton's Foundry, number 1. Number 2, the Government Printery trial. You can put the numbers over there, you can see them. 2A. 2 of the green, the blues are the Printery, and the yellows are the other ones, non-Printery. Brisbane Newspaper, Roma Street Railway Yards, the Government Printery in 86, and that was the milestone, government-owned power station, and Edison Lane, a private power station in 88. So up until this stage, all these other places were only limited to power in that building or in that site until the Government Printery was built. And that Printery power station, which was 2B, supplied Parliament House and the Printery and nobody else. It was just government owned. 2 years later, Barton and White developed a public supply system from Edison Lane. So that's what we in the industry generally call as the birth of the public system, where public could buy power, was 1888. But in fact, there was a power station operating before that. But it was very slow. The progress was very slow. The Edison engineer died. Matheson didn't do too good. Devonish, he was the gentleman that got the contract to put in the street mains. It was just interesting to see that was his price, 17 shillings and 9pence per chain. He was given only 20 days to dig it by hand. You can imagine, you know, in 1880s how much equipment they had. 12 inches wide, you had to dig 18 chains along the street with the larger 18 by 18 by 18 for the connection boxes, which needed more space. The route documentation was never found, and that's why when the tubes were eventually abandoned, sort of everyone forgot about them. Consulting engineer Edward Barton was employed to actually correct a lot of the difficulties, the difficulties they were having in getting continuity of the supply and problems with the lighting, until finally it was commissioned in '86, and the actual order was placed in '83. That was quite a long time then in that period. So that's what colonial Brisbane looked like in 1888. That's a lithograph, and that shows the government sector. And the red circle is around where the power station was. You can have a closer look at it later if you can't see it now. And Parliament House is right down to the right. You can see that's what the foreshores look like. Commissariat stores there, and all the shipping. The power station actually then came energised. It got going in 1886. And it went right through to 1909. It was just on 23 years. But for 20 years it supplied Parliament House, and another 3 years it supplied the Printery, until finally the power station could not supply the load. There were more efficient stations being offered, supplies being offered by the Electric Light Company, and so they switched supply. That was the total cost of the scheme. £19,000, and if you look perhaps later closely at the steam engine part, they had to speed up the belt drive, so they took this long, tortuous path by putting another trailing arm up in the attic to go through a series of pulleys. Later on they got rid of that, I think, but they generally did that at the one level. But from the steam engine to the revolutions required for the dynamos, which are on the right, they had to speed up the speed of the armature. Thomas Edison, I thought it's a good chance to give a plug to Thomas, the Wizard of Menlo Park. He said on the right there, he said, look, it takes 99% perspiration and only 1% inspiration, because he was just such a dogged inventor that tried again to make these lights work. They started off with all sorts of filaments. He sent people around the world to get all different types of material, like bamboo and cotton. He ended up with a cotton filament, and he patented that in 1879. He was born in 1847. He's considered America's really most successful entrepreneur. Held over 1,000 patents in the United States alone. He was a staunch advocate of DC, and when the limitations on DC became apparent, AC was able to solve the problem of distance, but he resisted. And so there was a great fight in America about whether AC was any good. So we were a bit immune to that out here, because DC lasted a bit longer before AC came in 1915. Still, he did develop the concept of a power station, and then a network, and putting down the underground mains and then connecting up customers. And his first two major ones that preceded Brisbane, of course, and others in the United States, was one in Holborn, the Holborn Viaduct scheme in London, and the one in Pearl Street in New York. When he died, he was so well revered in 1931, President Hoover ordered that all lights in America will be switched off for 1 minute. I think that's pretty impressive, to do that. That's the site of where the power station was. That photo was taken in 1892, just before we put up a plaque on that plinth. There's a plaque here. It'll be restored after the restoration work is done. But that's the side of the power station just behind the old printery. Edison worked to work out how to take copper conductors in wrought iron pipes. That's all he had available at the time. And so we think he used gas pipes or water pipes. They're very tough, we'll show them to you later. And he had to develop a technique of insulating the copper bus bars from the steel pipe, which was obviously earthed. So he used these techniques, and that was his original patent. That one there, showing 2-core insulated from the steel with millwood diaphragms all tied together with string. Very laborious to put these into the tubes, and that's why we want to keep the 20-footers. We want the museums to keep them. He made them in New York, sealed them, and then sent them all around the world. We believe Brisbane was the only place in the southern hemisphere that got them. Certainly they were fairly plentiful in America, and they were going to the other regional cities. Obviously, we all say New York, London, but there were other cities in the United States, smaller cities, that were using them in their central business district. Very little records are available to find out where. Then later on, he developed, that's the complete list of all his 2 cores. The number 3 was the one he selected for Brisbane. This one here, which actually proved to be a bit small for the number of lights they were putting on. So they had a massive voltage drop between the power station and the Parliament House. There were larger ones available, and these obviously they were used in New York and London perhaps, but number 3 was the one that we used here. Interesting numbering system. Number 1, number 1.5, number 2, and so on. In 1992, the route was finally found by Energex, and we have here today Jim Simmers, ex-Energet engineer, and Jim was one of the engineers responsible for relocating where these tubes were with Professor Prentice from the University of Queensland and Mackenzie. And so there was quite a lot of work done by Mackenzie and Prentice on analysing these tubes and doing the recovery work. These here that you see here are similar to what we found in '92. They're exactly the same. I think that guy came out in 2018. That's what they look like when they're cut away, the 2-core and the 3-core. Edison, I just wanted to show you this. Edison and Swan in the United Kingdom developed the incandescent light bulb, the one that would work sort of semi-permanently, about the same time. And they eventually combined worldwide to call the Eddy Swan Company, and so they didn't compete with each other. They had difficulties on who had the right patent. And Edison screw still supplies today, 135 years, 36 years Edison screws. But I thought I'd show you a photograph of his 1887 advertisement for his light bulb with the switch in the base of the bulb. And he designed these switches, though, like keys, so that people didn't get confused. People were used to using keys for gas. You turn the gas on with a key, so you turn the light on with a key. Until much later, and they decided to put the switches on the wall. This is what we have no photographs of what his lighting looked like. In 1912, that photo was taken, so there'd been a couple of restorations of the lighting. Barton had done quite a lot of work in '92 when the lighting was improved. But you can see, I wanted to show you that to show you some of the style of the lighting. They kept the gas lighting there. They weren't trustworthy of electricity so much, so they kept the gas lights as well, just in case anything happened to electricity. And it did. So that's what the dining room looks like today. You see how modern architects have tried to get this similar style of lighting. That's the lighting in the library in 1910. Presumably that's, we think, probably how Barton left it after he did most of his work on the restoration in 92, on the expansion in 92. And that's what the lighting looks like today in that same library. And the magnificent lighting in the council chambers, which is a long, long time since Edison's lights were put into that, just to show you some of the wonderful chandeliers. And these are the wall lights they've now got in the council. And the modern lighting there on the set of steps. So that's what the whole power station was to supply lighting. Nothing else, lighting. It's all about lighting at that stage. And Edison came up with this sign in the United States. Do not attempt to light it with a match. And people did. Simply turn the key by the wall of the door. And the use of electricity is in no way harmful to health, nor does it affect the soundness of thought. So that's the first part. I've really given you a story about lighting, about the early history, and now the actual dig and what we found. Stuart's going to take over.
Thank you.
All right, so let me just step you through where we are with the dig, how the dig came about, and then what we actually found a couple of months ago. So Brian had the lithograph, I've used Google, so you can see where we are, Commissariat store, down William Street. And William Street is where all the action took place. And in the 1880s, as Brian said, across the road here was the Printery, and that's where the power station was. Down the end of William Street, Parliament House, and the Premier of the day, McElwain, had been to Melbourne, saw lighting in Melbourne's Parliament House with a generator on site, came back here when Edison was doing the demonstration of the Premier and said, me too. And so Queensland Parliament was going to get lighting. Then if you look at the 1980s, some bits and pieces of the tubes were found as work was done in William Street and sort of freeways and roadworks and all those sorts of things. Small sections of the tubes were found. And I'll get back to this later, but that is typical of what happened around the world. As Brian said, these things were installed in many cities around the world, but particularly London, New York as the major ones. And bits and pieces had been found of these tubes here in Brisbane in the 1880s. But then if you go to 1992, getting my centuries mixed up here, this was the really big impetus here. There was some work done on, here in William Street, next to the laneway there, near where the power station was. And that's when Prof. Sid Prentice and Don McKenzie from Queensland Museum started a dig and found junction boxes and parts of cables and some significant lengths. And importantly here, it's when Brian was involved and Jim Simmons here down the front involved. And what they did using metal detectors and cable detectors at the time, they were able to trace they identified where the route was down William Street on one side and then Margaret Street swapped over the other and into Parliament House. So that was the significant turning point. Tubes were identified where they were, what they were, but there they lay. Until a couple of years ago, Destination Brisbane wanting to develop the integrated casino in William Street, a large area. Part of that, as you can see, if you go down, look at the William Street now, William Street becomes a car park for the casino and the resort. And the developers contacted Energex, who contacted Brian and Jim, who were still involved. So we had the continuity from the 92 dig through to now. We knew what these things were, we knew they were available. And then Brian and Jim got on their horses and started canvassing state government departments and others and the developers. And then everyone got on board. Yes, these things are worthwhile preserving. And so in February, we had a window of opportunity there where the demolition of the executive building was complete. The excavation of the car park was about to start. The workers had just got back from holidays. Bang, first week of February, we got in there. So the importance of this is that we had the continuity from the 92 dig going through. It said about to become a car park, so we had to get in there now or we'd lose them, right? So that was the important. And as I said, museums around the world, including ourselves, had small sections. We realised here there's an opportunity to get the original 20-foot sections, over 6 metres. So that was the real opportunity that we had. If we didn't do it now, then we're not going to do it. So lots of people involved, government departments, developers, the contractors, archaeologists. So everyone was well and truly getting involved. And then in February, this was the site. So you can see Parliament House in the background here. This is near just outside the street here, not just across the road here. And we're excavating up William Street up there. That's where the tubes went. You can see diggers at the end. And in the next photo, looking the other way, you can see the red digger. And he excavated, and then sort of as Brian said, these things were only 300 a foot deep, surprisingly. So carefully took the topsoil off, and then there was a camera, and in that whole site, they've got time lapse of the development over and so we will see a movie coming up where they time lapsed the whole excavation. Lots of people involved. You can see the tubes there in the middle. And these things, although the 2 core was laid in 1884, the 3 core in 1892, are essentially in the same trench, very just side by side. So we saw 2 tubes as we were excavating. Once exposed, we'll cut them with a reciprocating saw, power saw. I'll get to it. The insulation inside is a gooey tar stuff. With the heat of the saw, that did actually melt a little bit. Then very, very carefully lifted out. These things had been in the ground 134 years. We didn't know if they were just going to snap or bend or what, so very, very carefully lifted them out. But surprisingly, they were in very good condition. We had Minister Kate Jones there officiating on the day as well, and there were lots and lots of TV cameras and everything else as well. There was a little bit of damage, and this black gooey stuff oozed out, but there wasn't a real lot. And I've been working on these tubes since, and I'll tell you, that black gooey stuff is very, very hard to come out. So once they were taken out, we had to stop that black gooey stuff. So we had caps, heat shrink caps. So plastic cap, you can see them here on these samples here. They fit over, a little bit of heat, and they shrink onto them. So that seals them for transport. They're also scrubbed down, and this woman here, Tina King from Irwin, she's an archaeologist, and all of a sudden, there she is, sorry, over there. Sorry, I can see you, Tina. This is a real dig. So, but Tina spent most of the day or that week on the end of a power wire brush, cleaning them up and cutting them in fish oil. But sort of, the end results were brilliant, and they're all tagged and everything else. So, cut them, cap them, clean them, and tag them. And then, as I said, everyone came to the party. ProBuild, the contractor here, made up these special frames because we've got 6 metres, 20-foot lengths of tube, big junction boxes. These are the junction boxes here on either end. So we were very, very afraid of they got lifted, they'd snap. So They made these special frames that were very rigid and they could be picked up by a forklift in the middle, and that's how they're going to be shipped around the world, all tagged. And as I said, there were some that had corrosion on them, but remarkably, the tubes were in very, very good condition as we pulled them out. And they've been cleaned up extensively since, but nevertheless, for something that's been in there 134 years, and I put that down to the wrought iron and cast iron, but no oxygen, so there was no rust or anything like that, or a lot of corrosion at all. Remarkably, and that's a 2-core there. But looking at the two styles, the 2-core in 1884, positive, negative for the DC current. In 1892, when they strengthened that, because light bulbs don't patent, as Brian said, in 1879, they didn't fully understand voltage drops and all those sorts of things, plus there's a lot of variation in the bulbs. So when they put in the reinforcement in 1892, 3 cores, 1 core for Legislative Council, 1 for Legislative Assembly, and 1 for the Ella Street extension that had just been put on. So, and then they bound the 2 original cores together as the return conductor, the negative going back to the power station. They're very clever. I'd like to say just here the genius of Edison to me. All right, he realised power stations are getting bigger, I've got to distribute the power, sell more light bulbs, but he used everyday materials. The first one's here, copper. I can't help think that that section in the middle was a copper bar that was used elsewhere, and these were offcuts that he's used. As Brian said, it's millboard, which is like a compressed cardboard, with bits of cotton to pull these things through the tubes. In the later versions, with the 3-core there, that's just rope, bits of rope twirled around, and that's just holding it out. And then the insulating compound that was poured in afterwards, and in the junction box opened up, poured in. That's a combination, as we say there, Trinidad pitch, linseed oil, beeswax, and paraffin wax. Now, don't know why those fall, but I've got a theory and I'm going to try and get it tested. Again, Edison tinkering. He needed a compound that insulated, something that would melt relatively easily, that he could pour into the tubes and into the junction boxes, but then at room temperature, solidified. But because he's out in the field heating this stuff up, he couldn't have a very low ignition temperature, to be relatively high. So my guess is, but as I said, I want to prove this, that satisfied the flammability, the pourability, the viscosity when it's all heated. But we'll find that out. But again, everyday materials, or everyday industrial materials. And we suspect the tubes themselves were gas pipes because if you look carefully, when you open these ones here, in here you can actually see threads. So these were pipes that were used for something else. Probably a connection, and since gas has been superseded, guess is they were gas pipes. And he's just used them, these were lying around. The 20-foot section, that's what you could easily put onto the back of the drain, get into the laneways of New York City or London as you went around. And I suspect that's the way they were manufactured. Inside, connections there providing electrical conductivity, but also flexibility and expansion and contraction as you went through. So, what happens next? Well, what has happened? All right, we've had the dig, it's been tagged and everything else. Brian has led a charge contacting museums around the world. And we've had very, very good response from them. And emphasising here that we had to identify the actual owner of these tubes because they are of cultural significance. They're being given an export permit for that. So it was determined that Energex are the owners. There are electrical cables in the ground, so therefore there must be Energex, predecessor companies or whatever. So Energex are arranging that. We're providing these free of charge, except the museums are paying for all the transport as it goes through. We've been helping them do that. And impressively, we've had great interest. In Australia here, there's an electricity museum up in Toowoomba at Highfields, Applied Arts and Science in Sydney, and also importantly in Tamworth, which is the first city in Australia to have street lighting. Overseas, you can see Edison That's the Institute of Electrical and Electronic Engineers in the US, Smithsonian Science Museum, London. And Edison Park, coincidentally, have an exhibition planned for later this year where they're not only showcasing what Edison did, but showcasing the fact that Edison went around the world. Well, here's a prime example. In 1884, he's installing, or having his tubes installed in Brisbane. I mean, yeah, it took 4 months by ship to get across here from in those days. Really. So Edison went throughout the world, and so that they're all showing some interest, but very keen interest as well. Importantly, we're going to have one of their full length, 3-core and 2-core, in the lobby of the Extra building in Parliament House. So back to where they got a whole reason for it, with displays and interpretation and everything else. So we're working, in fact, Brian and I are going down to Parliament House to see the staff of the Clark after this meeting. But we've got a spot there which would look superb. It'll be seen by visitors, school kids, and it's important, I think, for school children to see this, to understand the heritage and sort of, the innovation and everything else of the day. So it's going to be in Queensland. And then finally, we're making smaller samples, and this is a backyard job, literally. That's why I've got the picture on my fingers of Brian and a couple of others. And we're just making small sections of these and fully restore them, but it's gooey stuff. But it's a bit of fun. I mean, yeah, what else do retired electrical engineers do one day? And there's lots of credits here, and as I said, Tina, Jim is here as well, and Brian has got to take a lot of credit here as well. But it's been impressive that sort of a lot of people and a lot of organisations have come together. So thank you very much.